Welcome to vector addition and subtraction video. I'm going to vector geometrically. So let's say we have vector v and vector w. I will translate w so that the initial point of w becomes the same as terminal point of v. It could be the other way around, as long as one initial point is the other terminal point. Now you can explain this as walking in direction v, magnitude v length, and then walking in direction w, magnitude w length. So the sum vector should start from initial point of v and then end at the terminal point of w. Now, what if both vectors start at the same point? This reminds you of adding forces. You've seen the parallelogram method. But wait, look at this vector. That's what we just did. When you're forming the parallelogram method, you're also using, it resembles the method we used in the beginning. So back to geometric representation, when initial point of one vector is the terminal point of the other. I like the geometric representation, but I want to have an algebraic way of adding two vectors. So let's put it on the xy plane axis. Now consider the vector v and component v1 and v2. Here's v1, here's v2. Now consider w and its components. So basically, think about adding the components, and I use vectors for components, so you remember v1 was positive. In here, w1 was negative. So you're basically going this much that way, then coming back this much. So you're adding the two x components, and here you're adding the two y components, and here's the x component of the sum, and here's the y component of the sum. So basically add component wise, right? So in 2D, it becomes, if I have a vector represented by components v1 and v2, and then I add it to another vector represented by components w1 and w2, the addition vector, see the addition right there, is going to be component-wise addition, v1 plus w1 and v2 plus w3. The same thing is true if you have three-dimensional vectors. Two-dimensional vectors add together, three-dimensional vectors add together. And in here again, component-wise addition. The adding is component-wise, yay. So now let's talk about subtracting vectors and geometry of that. So I'm trying to compute v minus w, vector v minus vector w. And it should be the same thing as vector v plus -1 times w. That is multiplying the vector w by a -1 to change its direction, because it's v minus w. And then adding the vector v. So here's changing direction. This becomes negative W. And again, I match one terminal point to one initial point, and I get V minus W. Subtracting vector algebraically, again, if you have two-dimensional vector represented by components V1 and V2, you subtract two-dimensional vector W1 and W2, then the vector represented by components V1 minus W1 and V2 minus W2 is the subtraction, as the difference vector. And same thing true if you have two three-dimensional vectors. Each component is the difference of the two corresponding difference of the two vectors.